welcome back. Now this is quite related to algebra. So it is a kind of problem that is very much to be understood, because it is bit tricky to understood. But follow my steps how I am reaching to the conclusion, and definitely it will be easy if I follow the step by step. Don't skip any step, otherwise you will be confused a bit. So let me explain the problem, then I will come back to the solution. So it says, suppose the prime number P and Q, prime number P and Q satisfy Q square plus 3P is equal to 197 P square plus Q. This equation it satisfied, and Q by P can be written in the form of L plus M by N, where M by N is less than 1 and L, M, N are integers GCD of M and N is equal to 1. That means M and N are not divisible by any other number. These are again some numbers which are only divisible by M and N and 1 itself. So that's why I am getting GCD as 1. And then find the maximum value of L plus M plus N. So this one expression is given where P and Q are the prime numbers. P, the ratio of Q upon P is L plus M by N, where M, N and L, M, N are integers. Condition is that M by N is equal to less than 1 and GCD of Mn is equal to 1. That means Mn are not multiple of each other, neither they are same. So these are the different integers. Find the maximum value of L, M, and N. This is the thing you have to calculate. Now I will start with the expression, this one. So if I write it here, Q square plus 3P is equal to 197 plus Q. It is a bit confusing equation. Mostly you cannot get any such uniformity to start with. So just follow the steps how I am doing, because there is a quite typical logic is there to understand. So I will write it here again. It is Q, bringing other part on the same side of the equation, minus 3P equal to 0. Now 197 P square minus 3P, and here I am taking Q as common, Q minus 1 equal to 0. Now as this is a expression, a quadratic expression of P, then I can say it has to be 0, because only if, so if I take this Q minus 1 is some sort of function of P, then this expression validates good. That means if I say that this expression is true only if Q minus 1 is equal to some function of P, let's say R, where R is a constant, Okay, so q minus 1 is a function of p, then this expression holds good. So if I take p is equal to r into p or something like let's say any constant lambda, so if I put it like that, p square minus 3p plus q will be lambda p plus 1 into q minus 1 is already I have taken is equal to 0. So if I eliminate p from each term, because p is not equal to 0, because p is a prime number and it is an integer, so the expression will remain with p minus 3 plus lambda into lambda p plus 1 equal to 0. Okay, here p not equal to 0. Now from here, if I express p, I will get lambda plus 3 on top, and here I will get 197 minus lambda square. You calculate at home, you will get definitely this expression of p. Now this, as p is prime, so the possibility to for which value of lambda p would be prime, so if I take this part is equal to 1, that means 197 minus lambda square, if it is 1, so something divided by 1, the number itself. So if it is prime number, then definitely is one of the solutions. So 197, so lambda I will get here from, it is equal to 14. So if I put lambda is equal to 14, I will get p is equal to 17. Okay, putting lambda I will get 1 here, so 14 plus 3, that means 17. So definitely the 70 is a prime number and it satisfies the requirement of the problem. From here, if it is p is equal to 17, I have taken q minus 1 is equal to lambda into p, that means q is equal to lambda 14 and p is equal to 17 plus 1. Okay, now another expression is given, that is equal to q by p can be expressed in the form of L plus m by n, where m by n is equal to less than 1. Now I know q value is this one, so if I write L plus m by n is equal to, q value is 14 into 7 plus 1, on the top it will come 14 into 17 plus 1, and bottom p is equal to 17. So if I try to make it like that only, so I will get 14 plus 1 by 17. That means comparing these two equation, two side of the equation, I can get definitely L is equal to 14, your m is equal to 1 and n is equal to 17. So this value I am getting from by comparing the sides. So now our task is to find L plus m plus n, the value. So if I take L plus m plus n, I will get L is equal to 14 plus m is equal to 1 and n is equal to 17. That means all total it will give you 32. So here is your answer. Kindly see the problem. It is bit tricky. If you want to try it in other processors also, I think you will not able to reach to the extreme of the problem solution. So definitely is a kind of problem that has to be a unique one. Just remember the solution. Sometimes it is very much needed that some of the solution has to be remember, so that it won't give you a problem, because you will not find any other way to solve it. Okay, not very meaningful solution. So you may try at home, so or otherwise you can follow my steps to understand it better. If any doubt comes, you definitely put in comment box. I will come back to your queries. Thank you for now. Good night.